Hello friends, in this playlist we are solving the problems related to transactions and database management. In this we are solving the problems related to concurrency and data control in DBMS. So we have already solved two or three problems related to transactions. Now this time we'll solve another problem which is also a tricky problem. In this we have to identify whether whether the schedule is conflict serializable or not. If yes, also we need to find the whether it is recoverable or not, and also we need to find that whether it is cascadeless or not. So in this problem we will learn everything at once. So first we need to find conflict serializability, right? For that, you know that we need a conflict serializable precedence graph, right? In the graph, if there is no cycle, that means the schedule is conflict serializable. So we'll start solving the problem. We start with T2's read of x. We find right of x here, right of x over here. Anywhere else we do not find. This read of x will not have a conflict. So let's make the ideal. Yeah. So T2 has a conflict with T1 and T3 as we saw, right? Both of them are read write conflicts. So T2 needs to start before T1 and T3, right? So that is completed now. Now we go to T3's write on x operation. Now this write on x will have a conflict with T1's write on x and also a conflict with read on x over here. So T3 needs to complete before T1 and T4. So T3 needs to complete before T1 and T4. Right. Now again we move to T1. T1 has write on x operation which has a conflict with read on x present over here. So we will have to draw an edge from T1 to T4. So T1 to T4. So that means that T1 should occur before T4. T1 should complete before T4. Again, let's move on to next transaction which is T2's write on y. So write on y, again we see that there is a read operation over here. So that will have a conflict. So write on y will have a conflict with read on y. So T2 needs to be occurred before T4, right? Now we move to read on z. Read on z will have no conflicts because I cannot find any operations below this which are having a conflict with read on z. Again, commit will have no conflicting operation, and these three will have also no conflicting operation because there are no operations being performed after this in transactions T1, T2 and T3. So this is our final precedence graph, and I cannot find a cycle over here. We can again check it. Okay. Okay, yeah, so there is no cycle over here. I can clearly see that. So no cycle, what does this indicate? That indicates conflict serializable schedule. Conflict serializable. So that is the first thing which we had to identify. So I'm erasing it this part. So I found that the schedule is conflict serializable schedule. Now I need to check about recoverability. How do we check about recoverability? So whenever there is a concept, whenever there is a question of recoverability, all you need to check is dirty read. Dirty read. What do you mean by dirty read? If some transaction is reading a value from some other transactions who wrote the value and it is still going on. I mean it has not yet committed. So reading values from an uncommitted transaction is called dirty read. So if there is a dirty read, then my schedule is definitely going to be non-recoverable. Right, so that is for sure. So I hope you got the point of dirty read. What is a dirty read is, let me edit, help you understand. So this is a write on x, this is a read on x, and now this transaction commits, right? So this read operation is called a dirty read operation because it is being readed from a transaction which has not yet committed. So before this read operation, if the transaction had committed, then it would not have been a dirty read operation. But since it has not yet committed, there are still a chances that this transaction continues to update the value of x, and this is reading a dirty value. I mean, it is an incorrect value, right? So this is called a dirty read because that commit was after the read operation. If the commit is before the read operation, then it is not called a dirty read. So we need to find that if there is a dirty read, then it is going to be non-recoverable. So let's examine the schedule which was given to us. Okay, so this read is not a dirty read because this is the first read. This is a write. This is a write. This is a write. Now we are at read of z. We see that if there is any previous write on z. No, we cannot see that. Again, there is a read. We see that there is a write. Okay, yeah, see. Now this is a classic case of identifying whether it is a dirty read or not. So this is there is a write on X, and here it is a read on X, right? So if transaction T3 has not committed here, and if it had committed over here, then definitely it would be a dirty read. But since transaction T3 has already committed, I mean it is final that okay, this is a value for transaction T3. Now this read operation is not called a not dirty read. I mean it is not a dirty read operation, right? Now we see for read on Y. Is there any write on Y? Yeah, we can see that there is a write on Y and there is a read on Y. But again, see, we can find out that T2 had already committed. So that means this is also not a dirty read. So we can finally find out that there are no dirty read operations. There are no dirty read operations. That means my schedule is recoverable also. And that's fixed. Now again we need to find out for cascadeless, right? Cascadeless or not. So cascading. First, we need to identify that what is cascading schedules. So cascading schedules is like this, right? Write on X, read on X, and let's say there is a system failure over here, right? So what do you mean by cascading schedule? So now, if there is a system failure over here, this transaction will have to roll back. And correspondingly, since this transaction T2 had read a value from T1, since transaction T1 rollbacks, T2 also needs to be rolled back. So this is the problem with dirty reads. So this causes cascading rollbacks, right? So this is called cascading rollbacks. Now, in the above schedule which we have given in the question, we can see that there are no dirty reads, right? No dirty reads, and all of the transactions are committing, and then only someone else is reading. So that means this schedule is cascadeless. Okay, probably this schedule is also strict schedule because all of the operations are happening after commit only of one transaction. So in case if it is asked that whether it is strict or not, you can see out the definition of strict schedules. Every strict schedule is a cascadeless schedule. So that's the reverse case in a Venn diagram. If we try to represent it, so strict schedule is over here, cascadeless schedule is over here. So every strict schedule is a cascadeless schedule. So that's fixed. So the answer for our question is the given schedule is conflict serializable, yes. Recoverable, yes. Cascadeless, yes. And also we find out that it is strict. So this was the problem solution. In case if you have any doubts, comment it down. I'll try to solve them. Do not forget to like and subscribe to the channel. Thank you for watching.